Okay, we're going to look at graphical analysis of motion. And first we're going to start with position versus time graph. So we can either have a position versus time graph, a distance versus time graph, a displacement versus time graph. On a position versus time graph, the slope of the line is velocity. If it's a distance versus time, the slope is speed. And if it's a position versus time, it's going to be velocity. So the slope is the velocity. So when it says how far does the object travel between 5 and 10 seconds? Okay, well here's 5 seconds. Here's 10 seconds. So how far it travels? It goes from 10 to 20, so it goes 10 meters. So in this question, we're just reading the graph. We don't need to know anything about physics. How far does the object travel between 15 and 20? Here's 15, here's 20, so it's staying at 30, so it goes 0 meters. During what time interval is the velocity 0? So the velocity is the slope. So we know on a graph, a 0 slope is a horizontal straight line. So if I look at the graph, that's between 15 and 25 seconds. What is the velocity between 10 and 15? So the velocity is the slope between 10 and 15. So any 2 points on this line have the same slope. Whenever you're taking the slope of a straight line, if it goes through 0, 0, it makes it easier. So we know that slope is delta y over delta x, which is y2 minus y1 over x2 minus x1. So if we do the endpoints, 30 minus 0 over 15 minus 0, so 30 divided by 15 is 2 meters per second. So that's the slope, which is the velocity. Is the object accelerating? On a position versus time graph, only on this type of graph, acceleration is going to look like a curve. So there's no curve, so the answer is no. Okay, now we have another position versus time graph. So this is our frame of reference, but it's starting here. So which section represents accelerated motion? That's the part that's curved, so that's section D. Which section shows the object at rest? So the object at rest means the velocity is 0, which would be a horizontal straight line. So that's going to be section A. The object is always moving toward the starting point, so the whole t-axis is my starting point. Okay, so you would think it's C, but what's happening, it's going towards the starting point, but then it passes the starting point, so the answer here is D. And then which section represents a constant of negative velocity, and this is quadrant run, so this is C. So what's happening here is I'm starting off a certain distance away from the starting point in the positive direction. So in section A, I'm standing still. I'm still moving away from the starting point at a constant velocity. I turn around, and with a constant velocity, I go towards the starting point. I pass the starting point. Then here, I'm starting to accelerate to the starting point. And then once I pass the starting point, I'm moving at a constant velocity. But this velocity is greater than that velocity because this slope is steeper. The steeper the slope, the greater the velocity. So those are position versus time graphs. So again, we had more practice. Now we're going to look at velocity versus time graphs. So for velocity versus time graphs, there's 2 things we need to know. So the biggest mistake that people make is they don't look at what type of graph is it. Is it a position or velocity? So on a velocity versus time graph, there's 2 things we need to know. Number one, we need to know that the slope is the acceleration and the area under the curve is the displacement. So it says, at what time was the car stopped? So here, that means the velocity is 0. So remember, I'm not looking for a horizontal straight line. I'm looking for a 0 velocity, which is here. So it's 0.7 to 0.8. At what time did the car have the greatest velocity? Again, I'm literally reading because this is a velocity versus time graph. So it had the greatest velocity from 0.2 to 0.4 hours. What was the greatest velocity? Well, if I look at this is the greatest velocity right there. So that is 60 kilometers per hour. At what time or times was the car accelerating? So again, I'm not looking for a curve here. A changing velocity is an acceleration. So here the velocity is increasing, here it's staying the same, here it's decreasing, and here it's increasing. So those three places, here, here, and here, we have changing velocities, which would be an acceleration. So 0 to 0.2, 0.4 to 0.7, and 0.8 to 1. So a changing velocity is an acceleration. So here I have a positive, a negative, and a positive, but it's still a changing velocity. So I can have a positive or negative acceleration. How fast was the car going at 1 hour? So at 1 hour here, I go up. And at 1 hour, I just read the graph. So it's 40 kilometers per hour. What is the acceleration at 0.9? So 0.9 is right here. So the acceleration is the slope of this line. So at 0.9, I'll pick my two endpoints. Again, this is 0, 0, and here's my other endpoints. I want to find the slope of this straight line because any 2 points on the line are going to have the same slope. So the acceleration is delta y over delta x, which is y2 minus y1 over x2 minus x1. So it would be 40 minus 0 over 1 minus 0.8. So 40 divided by 0.2 is 200 kilometers per hour squared. Again, sometimes we make mistakes on our calculator, so we can use mental math. We can move the decimal point over and say 400 divided by 2. So the answer here is 200 kilometers per hour squared. Here, again, we have a velocity versus time graph. The slope is the acceleration, and then the area under the curve is the displacement. Which section represents a constant velocity other than 0? So a constant velocity, this is a changing velocity, changing velocity, changing velocity, changing. This one, the slope is the acceleration, so that's something else, because that's a changing acceleration. So the only one would be A. Which section represents the greatest acceleration? That's going to be the steepest slope. So that's going to be C. Which section represents a changing acceleration? That's going to be E, which is called jerk. That's what changing acceleration is. Which section represents the greatest displacement? So this is the area under the curve. So again, if we want to look at the curve is meant by this. So we look at the area. So A is this area, length times width. Then again, for each one, we look at the area. If it's a triangle, it's 1/2 base times height. And we can have positive and negative. So if we break everything up, we obviously see that the greatest area, the shape, would be under D. Now, if I needed to calculate this and I had numbers, I could just break this up into two shapes that would be easy. So I would do the triangle, and then I would do the length times the width of the rectangle. So that's how, if I wanted to calculate it. So again, the most important thing is what type of graph is it? That is the most important. Let's look at if we can calculate one of those, because we didn't calculate the area. So if we look at this one, is the acceleration greater between 2 and 3 or between 5 and 6? So it's greater between 5 and 6 because the acceleration is the slope. The steeper the slope, the greater the acceleration. During which time interval is the acceleration 0? Well, on a velocity versus time graph, the slope is acceleration. So a horizontal straight line is going to be a 0 slope. So that's going to be a 0 acceleration. What is the displacement between 5 and 6? So the displacement is the area under the curve. So between 5 and 6, you go like this, and you break it up into two shapes. So you do the triangle and the rectangle. So I do 1/2 of 1 times 5. That's the triangle. Plus the rectangle, which would be 1 times 10. This is 1, that's 10. And 5 would be 2.5. Plus 10 would be 12.5. So the displacement would be 12.5 meters. What is the acceleration between 6 and 8? The acceleration is the slope. So between 6 and 8 is here and here. But again, it's always easier to find the slope of the whole line. So if you pick the endpoints, or you pick any 2 points that are easier, or you could just do it between 5 and 8, 6 and 8 if you want. So you could say delta y over delta x, 5 minus 15 over 8 minus 6 is negative 10 over 2 is negative 5, and that makes sense because it's a negative slope in quadrant 1. So this is negative 5 meters per second squared. What is the displacement between 3 and 4? So again, between 3 and 4, that's the area under the curve. So this is a rectangle. So this is 1, and this is 10. So length times width, 1 times 10 is 10 meters. What is the acceleration between 0 and 3? So the acceleration is the slope. So again, this is how we do these problems. The acceleration is the slope, and the displacement is the area under the curve. And that's it. And all the solutions are online to check your work.